Bueno, pues nada, buenos días a todos. Gracias por haber venido y estar aquí. Muchas gracias sobre todo a Michael Carter por haber aceptado esta invitación a darnos un seminario. Yo creo que es todo un honor tenerle hoy aquí, así que, bueno, yo creo que introducir a Michael nos llevaría mucho tiempo, voy a intentar ser breve, pero bueno, Michael es Distinguished Professor en la Universidad de California, en Davis, en el Departamento de Agricultura, de Economía Agraria y de Recursos Naturales. También es honorary profesor distinguido de Economía en la Universidad de Cape Town y es director del Laboratorio de Innovación sobre resiliencia, riesgos y mercados. Y también lleva la iniciativa de Quality Index Insurance Certifications, sobre los seguros certificación de los seguros indexados. Bueno, Michael es autor de numerosas y muy citadas publicaciones y su investigación actual examina sobre todo temas de dinámica de pobreza, de redes sociales de seguridad, evaluación de intervenciones para promover las tecnologías mejoradas entre los pequeños agricultores y toda una suerte de proyectos sobre el seguro indexado. Yo creo que Michael es como el padre del desarrollo de los seguros indexados en muchas partes del mundo. Desde luego en África es el pionero, el que ha desarrollado toda la parte de seguros indexados en Etiopía, Kenia, que es donde ha empezado el desarrollo del seguro. Ha desarrollado proyectos en un multitud de países, yo creo que por eso habla también español, ha estado en muchísimos países de Latinoamérica, pero también en muchísimos países de África y de Asia, ¿no? Muy implicado siempre con temas de seguridad alimentaria, de pobreza y de riesgo, ¿no? De análisis de mercados y de riesgo. Michael es elected Fellow of the National Bureau of Economic Research, también de Bureau for Research and Economic Analysis of Development, y también de la Asociación de Economía Americana de Economía Agraria. Bueno, ha ganado muchos premios por el impacto y la calidad de su investigación y ha sido editor y participado en los consejos editoriales de una enorme cantidad de periódicos, de revistas sobre desarrollo económico. También ha sido miembro del Consejo de Directores de Oxfam America y de la Grameen Foundation. Y actualmente pues, también sirve en distintos consejos científicos. De su actual, sus publicaciones son muy citadas porque además de ser muy buen investigador es un excelente comunicador, como veréis ahora. Y bueno, pues mencionando, o sea, con nosotros hemos tenido la suerte de que estamos colaborando en un proyecto sobre seguros indexados, pero también pues está trabajando en seguros indexados y temas ya también de finanzas, ¿no? De finanzas inclusivas. También van a unir, ¿no? Hacer nexos entre tecnologías financieras y genéticas y bueno, tenéis ahí, luego si queréis mirar en la web, desde luego su producción científica es abarcar todas siempre en el mundo del desarrollo económico y de la pobreza, pero ahora abarca muchísimos temas. Así que bueno, muchísimas gracias por estar aquí otra vez, Michael, de verdad es un honor tenerte, así que cuando quieras te damos la palabra. Okay. Bienvenidos también, me olvidé decirle, no solamente a los que estáis aquí, sino también a la gente que nos está siguiendo online.
Okay. Muy bien. Bueno, gracias para la presentación también. Very honored, thank you. So I'll speak in English, but I can understand Spanish. I just didn't prepare my mind for this material in Spanish. So, but if you want to ask me a question in Spanish, that should be okay. I'm going to give Eva a warning. I saw there was what looks like a very old picture of me where there's no gray in my hair. The warning is the picture's not all that old. No. But this is before I started doing index insurance projects that had made my hair turn gray instantly. Actually, I think it was the prior president of my country. That's when my hair turned gray for some reason, a little bit of stress.
You have enough reason.
So let's jump right in. This is work with one of my former PhD students, Mo Alouche. Was an extremely smart person. He's doing very, very well. He's at a small college in New York, now called Hamilton College. I told Mo the measure I'll present to you, I wanted to call it the M&M measure for Mo and Michael, but he didn't think that was very smart. My spouse, who's an intellectual property attorney, said we would be sued by a certain rapper if we said we were doing M&M. So much for that. The women in the picture here, this is Samburu County in Kenya. I'll mention I've been working with Alvaro, Enrique, and Ava on designing better index insurance contracts for this. So we actually did a very large study of a graduation program, an asset building program for these women. So these are some women who accumulated a few more votes thanks to that program. And part of that, if you're interested, was actually combining asset building with asset protection through index insurance. So I presented that paper a couple of weeks ago at Paris School of Economics. So we're not going to talk about that one today, but it is highly related to this discussion. So again, please feel free to interrupt me. I kind of prepared this for economists, but Ava told me we're not all economists, so I'll try not to get lost into the weeds that interest only economists. But if I'm saying something that doesn't make sense, please let me know. Okay, so let's get right in. So I'm going to build on just what I call here plain vanilla. I don't know if you use that expression, but if you have the simplest ice cream, it's plain vanilla, meaning not very interesting, but flavor's not bad, but not very interesting. So I'm going to use this definition of economic resilience, the ability to manage a climate shock or other adversity with minimal compromise with current and future economic well-being. That struck me as a pretty reasonable way. I actually got that from someone who was in the US government aid agency. And he said, here's our definition of resilience. And then he paid people and they went off and measured something else, which I didn't realize what they were doing at first. And later on, I found out, I said, wait a minute, let's go back to this sort of simple definition and think about it. So the key idea in everything we're talking about here is that we have to, if we want to measure economic resilience, and we can think of doing this at different scales, we want to measure that compromise of current loss and future loss. So the notation I would be using is T0 is going to be the time period in which we imagine a shock occurs. Okay. And what we know is we're going to have the superscript S means a unit that's been subject to a shock, like a drought shock that the women in the prior photograph face. And what we need if we're going to measure the loss is we need a good counterfactual estimate of what the income, or could be assets, could be consumption. I'm going to talk later about why it matters which of those we choose. But we need a good counterfactual measure of them. And if we can do that, then the simple plain vanilla definition says if we sort of accumulate, let's just add up here. Let's just add up the amount of that loss. And that's going to give us a measure of resilience, or something that we can use to create a measure of resilience. So it's not very deep thinking really, but that's the thought. I actually got this idea. I took macroeconomics as an undergraduate before many of us in this room were born. And we used to see these pictures of potential GDP of a country and actual. And when the country hit a recession, the actual GDP would fall below potential. And macroeconomists would talk about the loss of output, and they accumulate that. And if I remember the macro, I actually did very well on my macro exam in graduate school, but then I never paid any attention to it again because I thought it was boring. But we used to talk, at least at the undergraduate level, about what were called automatic stabilizers, right? Fiscal and monetary policies that would close that gap. Okay, so that's actually where the idea from this came from. I just remembered sitting in a macro class in about 1975, looking at these diagrams and saying, oh, okay, we were actually talking about resilience then as well. We just didn't call it resilience. So that's the basic idea that we're looking for. And obviously the challenge statistically, of course, is going to be to find that counterfactual. And we'll spend some time talking about it. Okay, so let's get at this. So why do we want to measure resilience? I know a number of you in this room are quite interested in resilience, and a number of organizations, governments, et cetera. I run this thing called Markets, Risk, and Resilience Innovation Lab. We used to be called the BASIS, and our funder, the U.S. agency, for international development keeps changing our name. So now we're the Markets Risk and Resilience Innovation. So anyway, but a lot of people, USAID, many other agencies became quite interested in resilience. And one reason they're interested is kind of a claim, there's kind of a public finance claim that somehow promoting economic resilience ahead of time is smarter public policy than letting bad things happen and clean up the mess. Okay? Now, my own personal suggestion is when we first formed this index-based livestock insurance, we were putting it together in 2008. And I was working with Chris Barrett, one of my former students at Cornell, and Andrew Mude, who's one of my grad students, who's now with the Africa Development Bank, but was with the International Livestock Research Institute for many years. We were putting together this index-based livestock insurance. And it was being launched at the same time that the government of Kenya, in collaboration with the British government, was forming what they called an HSNP, Hunger Safety Net Program. So we went to the High Commission in Nairobi, and we're sort of chit-chatting, and I probably said more than I got in front of my scientific skis, if you use that expression. I got ahead of myself. And I said to the High Commission representative, we can actually save you money. Okay, you're willing, the HSNP program at that time was trying to target people who suffered a shock and fallen into poverty, and was going to give each of those families $15 US a month. Okay, and I said, if you gave us money for an insurance subsidy, it would cost about $7 a year, as opposed to $15 a month. So I think there's a public finance case to consider. We could have called it a resilience promoting activity. And they sort of said, well, that's kind of interesting, but where's the evidence? So we didn't quite have it, but they did actually help us. They did help us get this Italy index-based livestock insurance off the ground. Fairly recently, with Sarah Jansen and Nobuo Kagami, we had a paper in the Journal of Risk and Insurance. We're using dynamic modeling methods. We show that can be true, that it actually can be cheaper for government to provide insurance and even subsidize insurance that's actually cheaper than the alternative, which is letting people fall into a bad economic state and then respond with a social protection program. Okay, so as I come from an era when people did more theory, I'll present lots of RCT stuff too here later on. But for those of us that don't take theory so seriously, you could say, well, sure, you can. As I was told by a referee of the paper not long ago, oh, anything can be true in theory, who cares? I said, this was really hard, the results are surprising. No, we don't care. Okay, nonetheless, if you're interested in that, this paper with Sarah and Nobu goes some distance down there. The paper's called something like, can asset insurance lower the cost of social protection? Something along that line. Okay, so I'm going to try to show you then that this measure that we're going to build here, fairly simple one based on what I already shared with you, also is really useful for these kinds of public finance discussions. It allows you to go back and see. Okay, so in terms of what I'd like to do for the rest of today, I want to say just a little bit, and here's where I need to be careful, because I've been lecturing on this to my grad students for many years, but I want to say a little bit about sort of the economics literature on shocks and what's essentially resilience. In the resilience measurement literature. Then what I'm going to do is I'm going to use a dynamic programming model to create some really clean experiments. Okay, and the nice thing about it is I'm going to manipulate the data generation process by changing parameters of the model, and that allows us to sort of see how the measure I propose, that we propose, how it might work differently in different when you face different kinds of dynamic economic processes. So I'll introduce the data generation process a little bit. I'll introduce the M&M measure, now called the LR measure for reasons that will become clear. I'll mention a little bit about measuring resilience at the individual level and give you an example, again, out of fake data of a policy evaluation. I want to talk a little bit about poverty traps and what that does to the resilience measure. And in particular, emphasize that, I was just giving a talk at Cornell a couple months ago, last November. And talking to Chris Barrett, some of you may know works on resilience stuff. He says, oh, we don't know if we should use consumption or assets or income, which is better to measure, sort of thinking about it in an error measurement framework. And I said, Chris, it actually matters a lot in terms of the dynamics, which of those you look at. So I want to make that point because I think it's kind of important. And then if I don't talk too long, I'm then going to share with you, show you that you can actually do this with real data. And I'm going to take, we had a paper just came out in the Economic Journal, which is looking at combining stress tolerant, specifically drought tolerant maize seeds with index insurance and sort of showing the impacts of that, over a drought sequence. So I'll try to go. So I need to watch my time a little bit, able to start throwing something at me, because I think it's probably pretty important to real data as well. So that's where I want to go. Let me stop right there and see if any questions or comments. Everyone's okay? Good. All right. So let me not get too far into this because, again, I'm not sure how many of us here are actually economists. But PIH stands for the permanent income hypothesis, which sort of looks at basically that literature sort of says, how do people set their consumption and how do they respond to income shocks? Okay. So the permanent income hypothesis was always that, especially if you're in a world of full and complete markets, if you're hit by a shock, then you look at your permanent income, you borrow against your future income, you bring that back so you can keep your consumption standard, and this will result in a small decrease in your permanent income, but it implies that if I do a regression, if I regress consumption over time on shocks, there should be very little impact. That coefficient, it'll be significant, I guess, if you have enough data, but that coefficient should be very tiny. And then some of that literature, as people started investigating this, said, oh, looks like there's excess sensitivity, meaning people's consumption is responding more than the permanent income hypothesis would suggest. Okay, now that literature never uses the word resilience. Okay, but in fact, what they're saying is if I focus on consumption, if my consumption is very well insulated from shocks to my assets, then that suggests I'm really quite resilient to it. So sort of connecting to our work, one way to think about it is what the permanent income hypothesis suggests. It's kind of a counterfactual, right? If you observe real people, you run these regressions, you're asking, compared to the theoretical model, let's call that the counterfactual, or what I say here, what people are supposed to be doing, in quotes here, right? If people are economically rational and subject to lots of other concerns, are people really doing that? And so that literature, in a sense, was comparing, stability of actual consumption to a counterfactual, but it was sort of an imaginary, underwritten counterfactual. So that's kind of where we're going here. Now, I'll just mention briefly, although I'm not doing a very good job of being brief, paper I think is really fundamentally important in this literature, which is a paper by Angus Deaton in Econometrica in 1991, where he said, sure, permanent income hypothesis is great if you have full and complete markets, but we all know most of us don't have full and complete markets, especially poor people. So he sort of resolves that kind of dynamic problem and asks himself, how will people who can't borrow against their future income when things go bad, what will they do? And how sensitive will their consumption be to shocks? Let me just give I've been using this phrase for a long time. You know the Sherlock Holmes story called the 7% solution? No? Okay, never mind. That's an obscure cultural reference. Anyway, the 7% solution was actually the heroin solution that Sherlock Holmes used. We won't go down that path. But basically what comes out of Deaton's model, he says, if you do a little bit of savings, then you can actually come tolerably close to the permanent income hypothesis, even if you can't borrow. Okay. Now it's a 7% solution. I don't know Angus Deaton well at all. Only met him once. But he basically says if you save about, in his model, it's numerically calibrated. If you save about 7% of your income, and your coefficient of variation of income is only 10%, then you can get tolerably smooth consumption, just with this simple rule. And so that's what Deaton does. And I think it's an important addition to the literature. And in the development economics field, it sort of spawned a lot of people saying, okay, let's see if Deaton is right. Right, so let me not go into all these papers. Did I send you the paper for this? Or did I forget? I think I did. Well, if I didn't, if you want the paper, Ava either has or will have it soon. So people started doing, regressing various things, including, they look at consumption on shocks for a permanent income in them, but they were also looking at drawdowns or building up of savings in response to shocks. Deaton was basically saying just sort of have countercyclical, when things go down, you draw down your savings, or pro-cyclical drawing down of savings assets. Now, these are a couple of favorite papers of mine that find a lot of weird stuff if you look into this literature. So these were papers that were focusing, Jalen and Ravalian, for example, look at data from China. Marcel Fachamps looks at data from Burkina Faso. Kazianda and Udry are also Burkina Faso. And they tend to find that the sort of simple expectations of either permanent income hypothesis or even the Deaton sort of version, they don't really work. Okay. Now, one that I think is maybe most important is the Fachamps paper. So in his paper, he's got pretty nice data on people, and he asks himself, they interview people, and of people who sold off livestock sort of as the savings asset, most of them sold in response to shocks. And then if you run a regression and say, let's see if on average people sell assets in response to shocks, the answer is no. Okay. And so Marcel, he sort of scratches his head. This is Marcel with Brasudry and Zvikas. I don't know who Zvikas is actually. They say this is sort of really weird. And they say people who sell assets are acting like they read Angus Deaton's work, right? They're smoothing consumption, but on average, people are not doing that. And then some work I've been doing over the years on poverty traps kind of literature suggests that in fact, consumption smoothing, that's not an objective, that's a potential outcome of a certain model structure. Right? No one tries to maximize smooth consumption. We try to maximize an expected stream of utility, at least if you think that way. By the way, I've gotten in trouble saying that to rooms full of anthropologists before. We think that's like the stupidest thing they've ever heard. So in any event, what comes out of some of the theory is that if you have a production set that has non-convexities, if you have this sort of core of a poverty trap model, and I'll show you an example in just a second, then not everyone is going to consumption. Other people are going to asset swing. That is, if I'm hit by a shock, the last thing I do is draw down my savings. I hold on to what I have. Okay. The anthropologists say, of course, who thought they would do otherwise? But that's another story. Travis Libbert and I had a JDE paper in 2012. We went back to the same data used by Fachamps et al. And showed that if you look at the problem through a theoretical lens, we use some threshold econometric methods, we show that in fact the population is comprised of consumption smoothers, people that the Angus Deaton would be really proud of, and people who are doing something totally different. Okay, they're in fact, when they're hit by shocks, they let their consumption fall and they hold on to the remaining assets. Okay, and I think it's pretty clear why people, if your income process depends on assets, you don't sell off your last cow, right? Because that means next year you're dead. In very simple terms. So that's sort of a quick, I think for me it was sort of useful to go back and think through the economics literature where we've been regressing things, behavioral things like consumption or income or asset stocks on shocks. And what I get out of that literature is that resilience, meaning back to my definition now, how much compromise is their current and future well-being when hit by a shock? For some people, that compromise of current and future well-being is going to be tremendous. Okay, and so to me, it's highly problematic, and it's important to think about it. Now, there's another literature on resilience that seemed to have grown up behind me, and I'm not an expert on this literature, so I'm not going to talk about it very much, although I started reading it more carefully. One reason I'm not an expert is Chris Barrett, who I mentioned before, wrote some papers fairly critical of some things in that literature, and he lost multiple friends, and people don't talk to him at parties anymore, and things like that. And I say, well, that's too high a price to pay for studying resilience. So I'm just going to say, if you want to read about it, you can read Chris Barrett. He sort of says There's a literature which got a lot of start from FAO, for example. They came up with some resilience measurement. USAID did the same thing. They basically say resilience is a capacity. You have a capacity to be resilient. So we don't know how to measure resilience, but we can measure the capacity. That's my quick take on it. Why can't we measure resilience? And then Chris has done some stuff which actually I don't agree with very much, where he says resilience is a normative condition. So resilience is the probability that in a stochastic world you can become non-poor. To me, that sort of confuses poverty dynamics with resilience. But I just sat down with Chris and we agreed. I was drinking wine. He doesn't drink much wine. He probably took a teeny sip. Oh, we agreed. We would just disagree on that. And then there's also a literature which ties in more with, I think, other disciplines a little bit, where there's some concept of equilibrium, and resilience can be conceptualized as a return to some kind of equilibrium state. Now, what we're basically doing, if you think about it this way, we're going to try to measure the equilibrium in a more dynamic way by having a counterfactual measure of where the person who was shot would have been without the shot, and recognizing that may be evolving over time. So we don't want to just see the people go back to where they were before, because if in fact they were on an upward trajectory, that's going to miss perhaps a large part of the cost of the shot. Okay, so that's all I'm going to say on the literature. Are there any questions of that? I hope I didn't lose too many people. Go down a rabbit hole. Okay. So as I mentioned before, I want to start off with a model that I can control and that I can ethically do bad things to people. Okay, so I'm going to shock random people in this model. I actually had one of my students we wrote together an NSF proposal, and it was rejected because we weren't going to randomize the exposure of people to violence. And I was thinking, that's about the stupidest referee report I ever got. You the NSF, really want us to go to Colombia and randomly pull people out and shoot them and burn their houses down? What are you talking about? They agreed to the point that, they had just lost their head to the randomista hordes, sometimes say. So the good thing about the model is I can do bad things to people, and it's just some little thing on my computer. I don't have to feel bad about it. So let me real quickly, how can I do, is there a pin click on that? Good. Okay, so real quickly, that's good, thanks. So we're going to look at a model that has a data generation, an income process that looks like this. There's a wage labor occupation. You just work casual wage labor, it doesn't pay well. I'm going to call that the poor equilibrium. So the women we saw on the top slide, when things are going bad for those women, they pick some wild plants, they process them a little bit, they try to make some money, they try to work for somebody near them that has a little bit of money, but it's not a very desirable kind of occupation. The alternative occupation, what we call the entrepreneurial occupation, it uses capital, and alpha I is sort of your comparative advantage as being an entrepreneur. Okay? So think of alpha I maybe being 1 for the average person, and somebody who's a really good entrepreneur is going to be greater than 1, and someone who's not a good entrepreneur will be pushing down. Okay, so this is a basic income structure. The important thing is we create a non-convex production set for those of you who are economists at least, and we assume that if you work full-time in the labor market, you W0. If you want to be an entrepreneur, you have to withdraw a discrete amount of your time. I'm going to call that discrete amount of time to be at least a partially full-time entrepreneur. Okay, so if I had nothing, I won't write on your walls. But the production set is basically going to look like this from above. So the outer envelope of that is going to have a non-convexity, an increasing returns to scale portion in it. Okay, so that's, and then, being typical economists, we say, okay, let's put this into a dynamic infinite horizon model. The key thing here I put in red is that your consumption for unit J in any time period T depends on, this is basically your cash on hand, to use different kind of language. That's your stock of assets that you have, price of 1, and then this is the income that you've just produced using this asset. Okay, you produce income this way. This is your equation of motion for your capital stock, which is subject to a stochastic rate of depreciation. So theta is a random variable the nature. So that's like the big drought events that hit the women and the cover slide. Okay, so you can accumulate capital, but there's this stochastic rate of depreciation in phase, which is going to influence what you want to do. So how does a model like this work? So not going to go into it too much, but this is literally, so here we're putting, this is your comparative advantages as an entrepreneur. So people over here are really good entrepreneurs. People over here, like my mother-in-law, who lived with me for 40 years because she was Greek American. She thought she was an entrepreneur, but she lost everything very quickly. And her K went to zero, so she moved in with us. And then people in the middle, okay? And then here is the amount of capital you might have at any point in time. Let's initially think about it as your initial amount of capital. And then the heat graph here represents the probability that you will end up at the higher income entrepreneurial equilibrium. So the yellow area basically, so these people in this yellow area, if they solve that dynamic problem, they will never end up at the high equilibrium. It's not worth their while. They don't have a large enough comparative advantage, or their initial capital base is too low. Given that this is an autarkic model, right? I didn't say that. You know, you have to you have a single income constraint, wealth constraint in your consumption, and your future capital have to come out of that, right? And so you can't go to the bank. So this is an elaboration, basically, what he did. So and then these red colors mean people basically have the darker reddish orange have probability 1 of ending up at the high equilibrium. So what you can kind of see, and there's other work if you're interested in this, there's basically 3 types of individuals. Type C people are people who have such a high comparative advantage in being an entrepreneur that even if they're going penniless, if their initial capital is 0, they will almost surely statistically get to the high equilibrium. They won't start there, but they will work their way there. So that's actually my mother-in-law's sister, who had a shop called the Martin Luther King riots, where her businesses in downtown Baltimore in the US were burned down. She went all the way down to 0. And within she died 25 years later, multi-millionaire, with lots of businesses. So how did she do it? I have no idea. Meanwhile, my mother-in-law was trying to follow her sister and, ended up penniless with us. Type A people are, if you think of a Roy model, are you familiar with the Roy model? Roy had this Fisher versus Hunter, who's what, right? Basically, this is kind of people with a strong comparative advantage to do one thing. These are another type. And these types, even if they're born rich, they will never accumulate capital. And then the ones that are interesting are the ones in the middle. Okay, so these are people who have the possibility of being entrepreneurs. But suppose you were right in here. So right in here, you have like a 30% chance you're going to make it. If you have a positive probability of becoming an entrepreneur, it means you're trying to accumulate capital optimally and go long in this diagram. But if you get hit by a shock, you'll go down. And if you fall into that yellow zone, then it's no longer worth your while in the sense of that dynamic problem to try to make that. So what's really interesting then is to sort of think about dynamics in a system if you have all 3 types of agents. So what I'm going to do with you initially is assume there is no type B agent. I'm just going to take them away. In fact, I'm just going to assume we have a type C agent. And we're going to sort of examine dynamics and that. And then we're going to bring in the other types and see how that influences what our resilience measure might be reflected. Okay. Can you take me back? Sorry. I think I went on that way too long. You're saying, where's resilience? Okay, good. Okay. So, so this I already shared with you. This is our basic cumulative loss measure. Oops, no, sorry, we got these two. Go back that's the wrong return, unfortunately. Here, I can take it from you. Oh, keep going. Do you want go one more, let's see where we are. Maybe one. Okay, that's good. No, I think I need one. Sorry. One more. Yeah, there we go. Okay. I saw the equation. I thought that we were back in the right place. Okay, so now keep all that in the back of your mind for a minute. Okay, so what I'm going to do is we're going to start with a scatter of people across those points. We're going to let them solve the dynamic problem. They get random shocks, and we can give them random shocks. And we throw some other noise in the data. So we create very nice time series of optimal behavior for different kinds of people solving that mathematical problem that we just looked at. Okay. Now, to make it look in a regression sense, we're gonna, as I mentioned, I'm gonna unethically, if you will, or I'm gonna ethically at least, gonna shock half the people in the sample at time zero. I'm gonna give them a big shock. They're gonna lose between 40 and 50% of their assets overnight, which is what happens to the one in that picture. Okay, shocks can be even bigger than that. And we're gonna run a regression that's very simple. So dt is just a vector of time dummy variables, and S here means that you're one of the lucky or unlucky agents in my computer that got shocked at time zero. Okay, so we can just run this simple regression. Okay, and there's noise in the data, so it's not, it's not totally degenerate. And the key thing we're actually interested in is delta S, right? That's the difference in income between a person that got shocked in time t versus another person. Okay, does that make sense? So let me just show you what it looks like. So here's the actual regression results. So here's time zero. We give some people a shock, and then we've estimated their trajectory and what happens to them during the shock. And here we're looking at their income. So they have an instantaneous, they've had this huge stochastic depreciation, a large shock. Their income collapses by about 50%. Okay, and then from there on, they solve that dynamic problem and they optimally reestablish themselves. The blue line are a well-matched counterfactual, because I'm controlling everything in the computer, so I know that they're very well matched. The people shocked were randomly selected. So if I'm not going to talk about statistical identification of these fake data, but that's basically what we're doing. Okay. So notice what I've indicated here, this script L. That's the thing I defined before. That's the cumulative loss between someone who was shocked and an appropriately well-defined counterfactual of where that person would have been. So you can notice the blue line is actually going up over time. That's because I set this up so people weren't yet oscillating around their long-term steady state. Okay, so there's still some accumulation going on. And so, as I mentioned before, we don't want to say the equilibrium for the red person is there and draw a horizontal line there. We want to see what the dynamic in the economy was. And if we were to simply say, did they return to where they were before? And there's a little bit of literature that does something akin to that. We're missing the dynamic of the system, and we may be understating or possibly overstating what happens. Okay. So the basic guts of so here's our cumulative loss measure that we're interested in, and it's just summing up those deltas over time or integrating and getting the data. In the particular case of the data, the sort of cumulative loss over the 9 years after the shock is 2675 for people whose income is the average income, essentially, let's say. So that's the cumulative loss. For policy analysis, we might want to take the discounted stream of that loss. So I just throw a discount rate of 5%. And in that case, this L prime, which just means the discounted cumulative loss, is 2084. Okay. So one way to think about this is, suppose you had a government that had a shock responsive social protection system, which is what the HSNP in Kenya was supposed to be, right? They were supposed to find the people that suffered shocks, and they were supposed to give them, they decided $15 a month was enough to push them back to where they would have been without the shock. Okay? So one way to think about it is doing nothing except reacting to the shock. The present value of that policy over this, or the cost of that policy would be $2,084 for this made-up data. Okay. So hold on to that number for a second. Before we start talking about policy, I just want to show you one other thing we've done to make the measure a little more interpretable. So basically, what we're going to do is we're basically going to normalize the loss in the following way. So this is L. R here is sort of the recovery zone. The horizontal line along here is sort of how far people fall. Okay.
So we're going to define resilience to make it a nicer measure. We're going to define it as the loss divided by the sum of L plus R, and then subtract that from 1. So someone who didn't fall at all, so if they instantaneously recovered from the shock, then the loss would be 0, right? And 1 minus 0 would be 1. So a perfectly resilient household would have a value, a resilience measure of 1. And if we go back here, if I fell all the way down there and I never recovered, and I went and I flatlined there, then if you look at that measure, that means my resilience is going to be 0. Okay, so this gives us kind of an interpretable measure when we say who's more resilient. And we can in principle sort of measure. Okay, so in sort of, if we ignore poverty traps, and I'm not going to ignore them for long, then this resilience measure should sort of go between 0 and 1, with perfectly resilient people at 1, perfectly non-recovering people. If that R thing squishes to 0, then this measure is going to be 0. Okay. Just to give you a hint hint on the poverty trap. If I fall this far, remember I showed you that type B person who was in the reddish area and the shock knocked them down? Then they go to a new equilibrium. Okay. And if this person were to go to a new equilibrium, they would go like this. In which case, the area would, the resilience measure defined the way I defined it, here will actually become negative. So this becomes a very simple way to detect poverty. Not that simple, but a way to detect poverty traps is to look at following shocks are the people that have negative resilience values. Because that means they've sort of changed, they're not recovering at all. In fact, they're going further down, which suggests they sort of changed their equilibrium destination. Does that make sense? So in our particular empirical case here, the LR measure that we have is 43%. Okay, so the interpretation of that is over the relevant time period that we have, then household recovery, they managed to close up roughly 40% of the total losses, just over 40% of the total losses that they have. So it has another kind of interpretation. Let me stop there for a second. Any questions? Okay, so again, what's key here again is the counterfactual. That's actually the hard part, right? We can track people who had shocks, but then notice I randomly distributed the shocks. But I'm doing this with real data. The question is, are the people that weren't shocked who are potential your counterfactual population, are they the same as the people that suffered or not? And that's the empirical math that you need. Just real quickly, because the literature out there on resilience capacities, we said, well, it might actually be useful to measure resilience at the level of an individual. I'm actually talking about FAO about doing this for level of a market as well. You need different sort of outcome measures, but the same thing could be thought of, right? So in the individual resilience literature, there's this discussion about resilience capacities. So my argument has been, which I said very nicely, so it's not to anger anyone, I try not to anger anyone, is if we can measure someone's resilience, then we can see what the correlates, if not the causal implications of that are. What really are resilience capacities? I don't know how people can measure it before they know whether it's truly a capacity or not, right? But I mean, is anyone here familiar with like the FAO kind of approach to resilience measurement? I mean, so they measure these capacities. I'm saying, oh, you think, social capital, or do you think access to markets, or you think this, or you think that? Great, if that's true, measure those things. Let's find a shock. Let's then estimate individual level resilience metrics, and let's regress it on these things and see if these things really do promote resilience. Because right now we don't know. People just have made up some well-founded, thoughtful stories, but they haven't really tested it. So let me not get too lost in this. This is just saying, in principle, we can take this down to the individual. So the big difference here is we're going to observe some characteristics of the person. Here's the shock person. Here's their counterfactual estimate. And I'm going to share with you some results in a minute where for this fake data, we just mapped on initial conditions and entrepreneurial skill. in the Tanzania data I'll show you before, we match on a pre-intervention set of variables as well as weather conditions that happened after we looked at it. So you, in principle, can do a measurement like this. So in the fake data, this is just a histogram of what these individual resilience look like. So the mean for the population is right about here. The mean resilience, which we estimated through a different method, but you can kind of see it's a central tendency of this distribution. But even in this fake data, you can see resilience, there's some variation. Resilience goes from basically 0.2 to about 0.7. Okay, I'd say that's not hugely interesting, but it's sort of saying if you can do a well-defined matching estimator somehow, then in principle you should be able to recover. And if this were real data, we'd say, why is this person's resilience only 1/3 of that person's resilience? Is it because they don't go to church and don't have social capital, or is it because they live in a more isolated region or less education? The things that are sort of out there in the literature, we say that should be subject. Our argument is with a measure like this, we should try to do that. The next point I'd like to share with you, I realize it's kind of a stream seminar. I'm bouncing around a little bit, is how can we use this to evaluate policy? Okay, so what I'm going to do is I'm going to go back to my computer and I'm going to introduce like what you might call a catastrophic insurance policy to half the people in the model. Okay, and then a shock, which is orthogonal to the introduction of insurance, is going to hit another half of the people. Okay, and then we want to see what happens and show how you can use this measure to actually go back to this public finance question. Is it really worth investing in resilience, or should you just do shock responsive social protection? So here's what happens. So let's see, I kind of, maybe I went too far. So here's the insurance policy. So it's kind of, we can think of it like IBLI, if we want index-based livestock insurance that I mentioned before. So we're going to have a high deductible policy that if you lose less than 40% of your assets, the policy doesn't pay you anything. Okay, and we can figure out in the model how we can actually figure out the pricing of that kind of insurance, which we do. And if you lose more than 40%, any incremental losses, the policy gives you half of it. Okay, so high deductible, and then it's only replacing 50%. Okay, that's actually a fairly cheap insurance. I'm calling it a catastrophic insurance because it only deals with things are really bad, and it's actually fairly cheap, right? Because you're only replacing half of the assets that were lost beyond 40%. Okay, so we can go through this. This is just the regression format for these curves then. So here's the people that didn't get insurance. The green line is now people that got insurance, so you can see what happens, right? And now everybody optimally behaves from that point forward. And the blue line there is still the people, they had insurance, but they didn't get anything because they didn't have a good shot. Okay. So notice we've got something new here. The thing I got into weird fonts. I was messing with, sorry, late in my memory. The G there is the resilience gain from this policy, right? So in other words, without insurance, then here's the cumulative losses, the area between the blue and the red line. When you have insurance, the cumulative losses between the green and the blue line, and then the difference between the green and the red is just the resilience gain from the policy. Okay. And so if you want to think about it this way, we can see these people obviously, they recovered more quickly, and then, they're approaching the equilibrium. They're going back slowly towards their steady state. So the question is that worth it? So one way to think about it is the present value of G, or that stream G, right? That's how much money the government could save in its social protection budget. Because it bought insurance for people, right? It didn't have to pay as much to the green households as it does to the red households. So the question is that actually good public finance or not? So to make that sort of a fair comparison, and notice it's a pretty lousy policy. Right? I mean, because it's catastrophic, it doesn't solve your small problems, your big problems. Right? So to do this, we assume that for 10 years, the government had actually been fully purchasing this lousy insurance contract for everybody. Okay, so that's the cost, right? And when we go through this exercise and we do the benefit cost ratio, we find the benefit cost ratio is 1.8 to 1. That is, for every dollar the government spent on buying insurance for everybody, right? Because we got to take that into account, right? For every dollar it spent, it saved $1.80 in discounted present value in reduced social protection obligation. Okay, so in this case, thank God, I didn't have to concoct it too much. You know, this is what I told the British High Commission in Nairobi, is that if they provided people insurance, they could actually do better. For every dollar of insurance, they would save more than $1 on social protection costs. And in this particular episode, okay, we see that it happens. Okay, any questions?
Yeah, just it's a very general question because I'm trying to put this in context with other literature. For example, when you mentioned the permanent income hypothesis, it seems like the model that you are generating is like generating trends. So you're not generating cycles around the life cycle or whatever. So that's why they evolve parallel. There's a change level that they evolve parallel. So in general, we expect that through the life cycle, you get ups and downs. So maybe when you accumulate, it's not that clear that you can calculate with your measure of resilience.
Sure. I mean, so there, I think it would, I mean, that's a great, we've actually talked about this a little bit. So first of all, to make the math, make the problem easy, it's an infinite horizon problem. So nobody's going to die or no one's going to reach the end of their life. And that's a lousy reason. The other thing we've done is just to make a clean experiment, we just allowed one shot. Now, the more realistic thing would be to allow shocks to randomly occur to some people. Okay, which is what we're going to see in the real data from Tanzania in a second. Okay, so that makes it harder to find the counterfactual, right? So if you throw in life cycle phenomena plus other ups and downs that are happening, then the challenge of finding the correct counterfactual. So in other words, you'd want, you know, if you know, I think I see the picture you probably have in your mind, you know that there's, for someone that's past the peak of their life cycle, we sort of imagine some decline as they move onward and their income and consumption will change. So I think the challenge would be finding someone else at the same stage in the life cycle who didn't suffer the shock. Okay, and similarly in the other data, we couldn't control the weather in Tanzania. So some people suffered shock in what I'm calling period 1. Some other people suffered shocks in period 1. So that messes it up. So when we do some of that analysis, we can bring in some additional controls to try to make sure we have the correct counterfactual. So this is, you're right, this is highly simplified, but I think in principle, you could incorporate those elements into it. And if I think about it less as a theoretical exercise and more as an empirical exercise, then I think it's the challenge of finding the correct counterfactual. For me, with my gray hair, is it Ava or is it you? I'm not going to say it, but I think does that sort of make sense?
Yeah.
Okay. Any other questions at this stage? Okay. Okay. Let me just show what happens when we bring in the poverty trap. Okay. So everything I was showing you before, remember, these are the individual resilience measures. They ran between about 0.2 and 0.8. Okay, now I brought in a richer array of agents, okay, including what I call type B people. So type B people are individuals who they may be on a trajectory to get to the high equilibrium, but if they lose too much, it's no longer rational in the sense of that dynamic problem to do that. Okay, so that's the essence of a multiple equilibrium. Some stuff Chris Barrett and I wrote a long time ago. We call that unnecessary deprivation. Okay, we call it that because, if you have zero entrepreneurial skill, you may be deprived in the sense of being really poor, because of the structure of the economy you live in, but, conditional on the economy you live in, too bad, right? Whereas people in this middle group, they actually have the capacity, entrepreneurial capacity in the narrow confines of the model. They have the capacity to be non-poor but their particular history, either they were born to a poor family or they suffered a sequence of shocks that pushed them into that, they end up being deprived as well. And it's not necessary in the sense that it is necessary for a low skill person to be poor condition. And when I say that, don't misunderstand me. I'm not saying people have to be poor. I'll leave that. Jesus said something like that, I think. Instead, what I'm going to say is, given the structure of the economy, right, then there's no other option. So what happens here? So what you can see immediately is happening is really a couple of things. So let's focus down here. Before I said the original idea of this measure is it's bounded between 0 and 1, with 1 being perfect resilience and 0 being non-recovery. Okay, now we have a subset of our agents in the model who got shocked, who are in that type B. And when they got shocked, they were in the red zone and they went down into the yellow zone. And then when they go to the yellow zone, you know, they before they did that, they were striving to have more capital, and then they changed their equilibrium. It is an individual multiple equilibrium model where stochastic events will cause you to shift from one equilibrium to another. And as I mentioned, as I tried to say before, anyone here and to the left is actually someone who has changed their equilibrium destination based on the shock they received. Okay? Now that's actually, I think that's actually really quite important. So let's just, so as not to go on too much, if we, with that poverty trap structure put into this model, what we see is, let me just focus on this. It turns out that insurance is even more valuable. Before its benefit cost ratio was 1.8, it now rises to 2.2, because what the insurance is allowing to happen is some of these people who fell below, right? The restoration of assets is not going to be, it's not going to save all of them, but it's going to put some of them back into a position of economic viability. And if they go back into a position of economic viability, then they can work their way back up to their what their counterfactual would have been. Okay, so again, as this says, and again, we don't want to take these numbers super seriously, but we can see what happens if you just look at the raw mean resilience in the poverty trap. It's actually 41%. I thought it would actually be a lot lower. I'll come back in a second. But when you put the insurance in, the resilience measure, so the average across this population doesn't quite double, but it comes close to it. So it makes a substantially more resilient population. And on top of it, it's really good public finance compared to the option of just giving poor people money. Okay, and that's the way we chose to do. The other thing that happens in this picture, some of you may have noticed it, the resilience measures when we just had one equilibrium, everyone was like a type A person. The top resilience measure is about here. It turns out we have some people in the model now who had very little capital because they're wage laborers, and when the stochastic depreciation hits them, they don't have much to lose. Okay, and so they actually look really resilient. So this is not, and this is where Chris Barrett would get excited, right? So this is not necessarily good news, right? It doesn't mean these people are not poor. It just means they got back to where they're counterfactual, okay? And as I've been telling Chris, if you want to focus, I don't know if you know the poverty measurement literature, people talk about the focus axiom. You only look at the class subset of the population you're interested in. You can focus the resilience measurement on the poor. But the reason I strongly feel that we don't want to confuse poverty dynamics with resilience is, you know, a lot of, you know, when you give these people insurance, a lot of these people move this way, and they are probably still poor over the lifetime of this model, but that's a tremendous increase in their well-being, right? So again, resilience is not per se a well-being measure. In our definition, it's getting back to your counterfactual. And you may want to sort of take that apart for different kinds of subpopulations, depending on what you're interested in. But to say, as Chris does in some of his work, to say, oh, they didn't escape poverty, therefore they're not resilient. I'm saying, if I normally live on 90 cents a day, and I fell to 50%, if I can get back to 90 cents a day, that's a huge improvement in my economic well-being. And $1 a day or whatever it is now, poverty line is arbitrary anyway, who cares, right? Who cares whether it's a dollar? And to say I don't care about someone that's, so think of someone who, two people, one, they both started at 90 cents a day. One falls to 50 and gets back to 90 pretty quickly. That's a huge improvement as opposed to being at 90 cents a day, falling to 50 and getting stuck. Right? And so I think our resilience measures need to sort of be attentive to the resilience of people who started out poor and remain poor. And it doesn't mean resilience isn't a good thing. It just means resilience is not the same thing as sort of part of the dynamics. And I think focusing this measure, so we could focus on the subset of population that we're interested in. And I haven't done that yet here, but we'd say, okay, how many of deeply poor people were resilient? How many of them escaped poverty over time? We can ask those questions, but I think we need to keep the conceptual clarity between resilience and sort of broader system dynamics. Anyway, that's my take for the last. Okay, any questions on this, and then I'll wrap up.
Michael, and then how would you consider here that maybe most of the ex post help and assistance go back to humanitarian aid to the very poor, but according to your graph, it's like they're already in a trap, no? And that's one question. And the other thing is that may not be resilience very closely connected to this entrepreneurial activity or ability, no? That's not only maybe intrinsic, but maybe also influenced by policies or external, because it seems that this entrepreneurial ability could also be a way to measure this resilience capacity, no? Or is really closely connected to a resilience capacity, as you.
Yeah.
How is it related?
So in the model that I showed you with the funny heat graph, right? So I mean, in fact, there are people with extreme entrepreneurial ability or strong comparative advantage. They will always recover. And in fact, they recover very quickly. Those of you know basic sort of solo dynamic models, they are very far out of steady state because they're a high ability person. They're really shooting for the stars. That's actually my aunt. I didn't know that, right? So when she lost all her assets, she went and worked in a grocery store, and somehow rebuilt herself up, very, for doing it. And she knew where she was going, a multi-million-dollar thing, which was, given her entrepreneurial ability was where she was going. So the ability to be entrepreneurial, number one, it would in this sense could be considered a correlate of resilience. I suspect, and I haven't done this yet, I suspect most of these people with higher resilience are actually the people with higher entrepreneurial ability. That's just based on my understanding of how this model works, but I haven't actually looked into our fake data. The other thing you're kind of hinting at, I think, I heard two other things. So one of the other things is, I treat entrepreneurial ability here as fixed, and that's probably not true. Some of us are better at it maybe than others. That's actually the other paper that I recently presented because we did a lot of stuff looking at mental health and how that influences the way asset transfer programs work. So I think that's really important. The other thing is what I'm calling the cash transfer program is like a no leaky bucket scenario. So when I say that that benefit cost ratio is 1.8 or 2.2 to 1, that's actually assuming that you can perfectly target aid transfers. You don't have to give any money to Oxfam, who I used to be on the board. They're not going to suck off, even 5 or 10 or 15%. You're not going to give it to the wrong people. So it's actually a really, and I think this is a really important point because we're getting these strong results, assuming it's costless to deliver shock responsive social protection and that it's perfectly targeted. Now notice that's actually different than the insurance. Okay, the insurance is given to everybody, right? You don't have to target it, right? Whereas all of us in reality know when you do any kind of social protection, huge amount of resources and hand wringing is done about how do we make sure the right people get the money and when do they no longer get the money, and then there's pilferage, and you're talking in the car about the Africa risk capacity and where does that money really go? So this is kind of the exercise, I think, is you know, kind of implicitly stacked against the case that, I mean, I'm not trying to make the case that everybody should buy insurance, but you know, the way the analysis is being done, it's a very naive representation of shock responsive social protection being zero cost to deliver, perfectly targeted, whereas insurance is just this thing that's given to everybody in the model. So, yeah.
This debate about, thank you very much for your presentation. I think it's especially interesting, the definition and estimation of resilience. But the debate that you present about ex ante policy or ex post policy, I remember in my time in FAO was the typical discussion about this dichotomy about ex ante ex post. And ex ante, for instance, in FAO, and I was working in FAO, is must be development aid, and the programs of FAO is for development. But WFP, the World Food Program, is much more focused on emergency aid.
Mm-hmm.
My experience in some countries is the best option is combining both.
Mm-hmm.
Development aid plus emergency aid. In the case of insurance, that is also a case of this kind of debate on ex ante or ex post, is also very interesting.
Mm-hmm.
But in the case of Spain, for instance, that we have a very strong system of insurance policy for agriculture, we have the combining the both measures. For instance, we have emergency aid in some catastrophic situations, but also the policy insurance subsidized by the state. And in our country, to access to this catastrophic aid, emergency aid, is just for the farmers that has an insurance.
Okay.
Combining
so
both, you understand? No?
Yes, I do.
Just the farmers that has an insurance can access to this extraordinary catastrophic aid, for instance, in drought. This is a very interesting possibility, combining both.
Yeah.
My question is, do you think, based on your research, that maybe could be an interesting policy solution?
I do, actually, and it's, I'm going to come back in the next two slides, which are the last substantive things I think to be done. We'll touch on part.
Maybe my question is too.
No, it's not. They're two. I think there are two sides of it I want to speak to, but let me just speak to that one element. I actually think what you just said makes a lot of sense. And the way I've thought about it is, it makes a lot of sense for government to purchase. You all use the language of risk layers. For the government to purchase insurance coverage for the catastrophic risk layer, and then let people build on top of it.
Exactly.
Let me give you a little story. There was a guy with a wonderful, very Spanish sounding name, Milton von Hess, who was Peru's Minister of Agriculture. Anyway, you all know Latin America has a really interesting history. So I was sitting with Milton von Hess in a thing, and Peru has a program called Seguro, organizado, catastrophic. And it's basically a kind of a bare bones, geographically targeted kind of cash transfer when things go wrong. Okay. And Milton is sitting there whispering to me, he says, "This is the stupidest thing I've ever heard." He says, if you're investing in your farm a lot, you get the $50. And if I'm not investing at all, because he was thinking about your comment too, actually. If I'm an old guy and I'm like checked out of farming, I'm on the downside of the life cycle, right? And we both get the same thing, and so how is this going to really be a development lever if you have this? So what I've been trying to get some people interested in, unsuccessfully largely, is kind of a variant of what you're saying, is let the government pay for this base layer. They can implement it however they want. It could be insurance or it could be cash transfer, doesn't really matter. You're adding you only get that base layer protection if you then protect yourself against some other layers of risk. And I actually think for a number of reasons that would be a really smart thing to do, because the government could, if the government's going to use insurance, they can make the market by buying a large block of insurance. And then if you're good with remote sensing like Enrique, you can downscale individual products for individual farmers to build up. So thank you for that, because that's actually, I agree, I couldn't agree with you more. The other thing I wanted to mention, and I think it's the last thing I'm going to try to squeeze in. Did I do something? Sorry, there were two things I lied. But let me just, I'll try not to look at the slides so I don't say too much. What this is showing in a poverty trap model is that, so think about two people, and one of them just falls into the poverty trap and the other one just misses it. Okay, their future dynamic behavior will be incredibly different. Okay, the person that fell into the poverty trap is going to de-accumulate, now have excess assets compared to the new equilibrium, right? So the optimal thing for them to do is draw down those assets and smooth consumption. Okay. Now, if their neighbor, their almost identical neighbor, did not quite fall as far, or maybe they were slightly better entrepreneur, and they stayed, they didn't go into the yellow zone picture, that person is now going back to the high equilibrium. Okay, they don't have a capital market, so it's autarkic self-finance. So that person is actually, if we look at consumption, the one that's not trapped is going to have lower consumption in this thing for 5 years than the person that is drawing down their assets and smoothing consumption. In the long run, the red line person is better off than the yellow line person. But if we had looked at consumption and we only had 3 periods, we'd say, oh, look how resilient these yellow line people are. But they're not really resilient. What they're doing is they're living off assets that they no longer need, and they're drawing them down. So I mentioned this work we did in northern Kenya, an asset transfer program. Part of what we were looking at is people that were not in, let's just call it, in the mental health condition to become entrepreneurs. They actually were really good consumption smoothers. They were given a couple $100 worth of assets. Come back 3 years later, they've been drawing it down, and they've got like $50 left, right? And the other people, right? And so they've been paying for their consumption out of the sale of assets. So anyway, I think in a world of poverty traps, we have to be really careful. You know, I mean, I know there are big debates, thanks to Angus Deaton and others. What can we measure better? Consumption, income, assets, blah, blah, blah. But a simple dynamic model will tell you, at least if you're in a world of multiple equilibria, you better think pretty hard about what you're looking at, because you could actually get exactly the wrong answer. You know, again, if you had data that was going to go on for 10 years, you're probably fine, but most of us aren't going to have that kind of data. So the final thing is that I just want to, this Boucher et al. Paper, this is the one I alluded to earlier. So this is a very large, it was actually a Mozambique, Tanzania, 2-country, multiple region RCT to look at resilience building technologies. Okay. So what we did is we worked with CIMMYT, those of you maybe the International Center for the Improvement of Maize and Wheat, and we took their drought tolerant maize varieties and combined them with an index insurance product that was meant to complement. Okay, so what I've done here, and so we have an RCT, so we have people that get randomly selected to get this bundle. I'm just going to focus on the bundle of insurance and insurance and drought tolerant seeds. And then we got some control group people, which we're going to look at here. And then Mother Nature distributed shocks across the years of our study. Okay, so econometrically, we can, with not too much magical stuff, right? We can look at the impacts of shocks, current and future, on both the control group and the treatment group. Okay, and the blue line here, this is now control group people who did not get shocked. Okay, so that's their account. If you believe Mother Nature randomly distributed the shocks, which I'll stand up here and say, of course, Mother Nature did that. I don't really know if that's true, but I think it's, as the identification assumptions go, it's not terrible. So here's the time path for the blue line people. As you can see, year 3 was not the world's greatest year because the control people had a little bit of dip. This is their net maize income, which is about, this is one thing we measure relatively well, and that's about 70% of total household income. So it's not everything. for these households. And then the red line people who suffered a very major yield shock. Okay, and what happens is their resilience, as you can kind of see, their losses are huge. Okay, and the Economic Journal paper goes into this in more detail. But the year after that, not only these people have a 50% income drop, they totally decapitalize their farming. And so when you look at if you take what's behind this, right? They didn't have money for inputs the year after. Their area planted fell by about 40%, I think it was, et cetera, right? So it's an extremely slow recovery. We ran out of money, here, so we don't know, what eventually happens, okay? And we see there's not only a decapitalization of the agricultural enterprise, we also have food security measures, and there's also a consumption drop of about a 25% increase. If I could have graphed this with food security, so the blue line's chugging along unperturbed, and the red line people in the control group have a substantial drop in food security. So they were hit by such a shock. Not only did they end up decapitalizing their agriculture pretty substantially, but their consumption took a pretty bad tumble as well. So what happens to the treatment group? Okay. So the green line over again, these are econometric estimates. They're not in the EJ paper. But it's the same data. If anybody's interested, I can point you to it. The green line, and this is where I want to come back to your question. The green line shows what happens to the control of the treatment group people who were shocked. And the outcome is, if I dare say, shocking. Okay, if you can see what happens. So the green line here is what's going on. And they actually didn't fall as far. Okay, they fell about a third of the distance. Okay, and that's because the stress tolerant seeds they had actually worked fairly well in farmers' fields. So the Summit people, at first we didn't think we had any results, and they were really angry, but they became cool with this eventually. But the really interesting thing is, and the EJ paper does talk about this, the year after the shock, treatment group people intensified their investment. So what the resilience technologies did was it kept them from falling as far, but then they had an insurance contract that gave them back their inputs. And what did the farmers do? They didn't just take what they had been given, they doubled down. In other words, they intensified their investments in the improved drought tolerant seeds, because most of these farmers, the control group, are just using local seeds, no fertilizer, very basic kind of agriculture, right? And so when we look at it, we see what I've labeled here a resilience dividend, okay? So not only do they get back to their sort of counterfactual, they go past it, okay? And I call that resilience plus, or the resilience dividend. And it's this idea that there's a very tight linkage between ex ante protective behavior and ex post. Now, the EJ paper actually talks about this a lot, because if I put up here the treatment, if I look at the treatment group who did not get shocked and therefore didn't observe the technology was working, they become just like the blue line people. They walked away from it. They said, okay, you idiots, we dabbled in this technology, we spent a bunch of money, and it didn't do anything for us, right? And so there's some very subtle messages here. But, but the positive part of the message is that when people, farmers will experiment a bit, and if they see it work, then they go, great. And this creates this so-called resilience dividend. So I won't go into it. I think it's, basically the game we play here. First of all, this resilience of the control group is about 18%, using the same metric we talked about before. So they're barely resilient. And then the rate of return on this is about 7 to 1. Okay, so the fake data, I had a 2.2 to 1 in the presence of poverty traps. Here, if ignoring the resilience dividend, saying, well, what this allowed people to recover right away, they more than recovered, right? But even if we ignore that for the moment, right, there's a tremendous payoff to this kind of thing, because it's not a very expensive insurance policy. The seeds aren't that expensive, so we sort of cost all that out. So we get this sort of 7 to 1 kind of number. And then if we bring in this sort of resilience dividend, that sort of doubles that doubles the return to building resilience, which is where, you know, in the olden days, I shouldn't put you in the olden category with me, but, you know, we used to talk about relief to development and stuff like this. And so, I mean, this is, you know, this just jumps right out of it. We've been working a little bit on the, looking at the distribution of resilience measures. Okay, so the blue line here is, this is the resilience measure. Here's 0, here's 1. And this now incorporates the additional value of the resilience dividend. The first thing you might, first of all, there's some people that have negative resilience, but not too many. So, you know, poverty trap would suggest there are more people back here. We don't actually see that in our data. Most people are slowly creeping their way back up. Okay. Interestingly here, for the first 40 to 50% of, these are cumulative distribution functions for these measures, they're basically overlapping. Okay. Now, it turns out this was an RCT, right? The participation rate or the compliance rate with the treatment was, surprise, surprise, 50%. I haven't actually looked at this yet. So this is really, this is a portrayal of an intent to treat impact on resilience, right? So we know that half the people who were offered the treatment didn't take it. And when we look at our individual resilience, and I literally got this, what we see is for the, you know, for about 50% of the population, they look like the control group, but I'm willing to bet some amount of money, not a lot, but these are probably the people that were non-participants in the treatment. And then the other people that are up here with much higher levels of resilience, those are presumably the people that voluntarily, you know, took up the insurance, because this was charged, right? This was not given to farmers. Farmers had to pay for the seeds, they had to pay a market price for the insurance. So again, I'm not entirely happy. This is based on some matching methods. We're still sort of struggling a little bit with this, but I wanted to share it with you a little bit to say, you know, not only can we get these kind of average effects like we see here, but we can actually dip down into the individual level. And I think we have a lot of noise in here that we're going to have to keep working on, you know, finding better matching methods. But the point is, you can take these fairly basic ideas, right? So I started off with totally fake data, and try to say, look, we can measure what I think most of us, at least as economists, mean, you know, but in terms of by creating a roughly 0 to 1 measure that seems to capture what we mean by resilience. And on top of it, you can actually use it to answer all sorts of interesting policy questions, like, is ex ante provision of resilience, you know, a good thing or not? And again, I think on top of that, actually, we just got a grant from the Gates Foundation that we call Resilience Plus. So we sold them on this idea that if you make people more resilient, you'll actually open a pathway to a higher kind of equilibrium, which comes out of any or most economic models that you can think of. But you know, I think actually doing it in practice. So that's work we're doing now in Bangladesh and Nepal and maybe Ethiopia, maybe Zambia, to sort of see if, you know, you create this set of tools. Not only you make people more resilient, but by making them more resilient, you make them more willing to invest because they can take the chances. So anyway, I don't think there's anything particularly important there. We're trying to do this with LSMS data, so if anybody wants to get gray hair, you're welcome to join into that venture as well. But we're working with some people at the World Bank, you know, to sort of say, okay, how can we, you know, how can you apply this? Can you go into LSMS? So they've got these nice LSMS-ISA integrated survey of agriculture data. I think many of you will be familiar with it, from about a dozen, maybe not that many, 8 to 10, 12 African countries. They're long-running panels now. And there's lots of shocks in there, right? So we're in the process now of trying to take that data, measure the shocks, find you know, can we really find a good control group? Alvaro, you're making me feel nervous about old people in there. And now every time I look in the mirror, I'm going to remember, oh yeah, what about that life cycle stuff? So you know, those are real empirical problems that I think are part of it. So let me stop there. I talked too much. I'm going to habla more. As you know that. Thank you for your attention and questions. And I can sit here and talk for as long as you want.
some doubt about how would you control when you have data? How would you control for the dynamics? I imagine that your positive aspect of resilience might imagine you are living in an area where you have a brilliant entrepreneur that really has this positive impact. Maybe the neighbors will follow the same idea. So that will affect the dynamics. So the dynamics might depend on the groups, or is there a way to control for those aspects so that?
Yeah, I mean, in a sense, that's like any kind of research design question with an RCT when you're worried about spillover effects. And so that's another part of my brain worries about those kinds of things. But your point is very well taken. I mean, if you talk to people that work for International Rice Research Institute about the Green Revolution in India, you know, they'll tell you farmers are jumping over the field into the experiment station and harvesting the grain so they get the magic seeds and all this other stuff. And there is, I mean, I think farmers do learn from each other. Some of you may have seen a paper I did with Dean Young and Rashid Laja in an AEJ applied a couple of years ago, where we showed extremely strong spillover benefits from a temporary input subsidy program. You know, so in other words, some people got in the same community. Some people got a subsidy, their neighbors watched them, went pretty well. In the next year, the impact on the neighbors are huge, right? So if that happens, then this will completely mess it up. So the way we normally, you know, in an RCT design sense, what we would try to do is, you know, let's if we're going to do a resilience program, let's have a counterfactual control group that's outside of the social domain or geographically isolated. But again, that then gets to be a little bit difficult. So, I mean, like with the LSMS data, our first order of business is just to ask ourselves, can we actually measure resilience aside from any intervention? And then if we do an intervention, then we have to worry about the kind of spillover that you mentioned, because I think you're exactly right. So that could potentially, you know, mess up. So if the blue line starts rising up here because they learn from the green line people, then we're in trouble. In this case, these were geographically segregated. So the blue line people could not learn from the green line. They're not very easy. Question.
Thank you very much, Michael, for your talk. I really interested. I think it is very interesting. I wanted to share with you some ideas because we have been working on resilience at farming system level in Europe. And I really like to see that we have some kind of parallelism in our studies because we have been studying resilience as a capacity. And we address 3 different capacities that is in line with the level of entrepreneurship, I think, because we have been addressing the capacity of being robust, the capacity of adaptation and transformation that I think is really related with the level of entrepreneurship. If you don't have any interest in entrepreneurship, you would like to be robust. And if you like changing, you are very entrepreneurial. You have this high level of entrepreneurship. But what we saw in Europe, because I think that this is very related to the region you are studying resilience, in Europe, when there is some kind of trade-offs between these capacities, because if you, for example, you support the robustness, this capacity of being robust and recover very fast from shock, maybe you are hindering your capacity of transform. And this is, for example, what we found when we apply this kind of subsidies, or maybe also applying or supporting the insurance. You are giving some sign to the farmers to keep as they are. So if they are keep us in the status quo, you are hindering the capacity to change and to adapt to. So I think that you also say that those that have more capacity to be more entrepreneurship, they are more resilient. They are in the right side of the figure. So what do you think about this? I think that one of the conclusions we get is that we need subsidies or we need to support this insurance, but giving some kind of incentive to farmers to change, not just to keep as they are. Mm-hmm. So what do you think about this kind of insurance or this kind of incentive for farmers to change?
Yeah. No, I agree with the concern that insurance can subsidize people to keep doing what they're doing, or it reduces the pressure on them to adapt. And so then I think I would think about it the way I think you just suggested. You know, is there a way to you know, tie that kind of protection to adaptation? So we heard an example a moment ago. You only get the government subsidy for catastrophes if you've also taken some other steps. So I think that's probably the right way to do it. And then I get into these, probably like a lot of you in this room, you know, discussion, should insurance be subsidized at all? Because if you subsidize it, you start to reduce the price of risk. And so people doing a little calculation say, well, why should I pay a lot of money to adapt? You know, I have this other risk management doing what I'm doing. So I think those are really important things. I guess what I hope this work maybe can add to what you have been doing is there a way to take this to actually measure resilience, right? So it's, again, we have things we think make people resilient and give them the experience, but if you could actually measure it. So Ava knows that, and a couple of other people in this room, I happen to have a particular weakness for wine. So I was in Bordeaux last week as part of a very fancy wine tour, and almost every place we went, climate change was the first topic. So in Bordeaux, you know, the more go-getting types, they're whipping up Merlot, and they're putting in Cab because they think Merlot will over-ripen with the climate shocks that they're getting, and nobody wants to go organic because they want to be able to spray. You know, it was raining there every day, so they're all freaking out about mold and mildew and blah blah kind of stuff we don't worry about in California, the home country where I live. So you know, but let's sort of think about that for a second. If we tracked if we could sort of isolate the more, I think I want to do a research project in that. If we could sort of track the bottle prices or something, right? The more versus less, you know, kind of entrepreneurial farmers or whatever it is we think these capacities are, right? As they get mildew shocks, as they get temperature spikes, and the things that are coming around them, like, you know, some of them are going to get, you know, the ones that aren't adapting are going to get really overripe, flabby Merlot. Even people in California to make, there was a movie, what's that movie called? I always like to tell my students to watch movies. It's more, you know, if you do math, you have to watch movies too. It was a stupid movie. Anyway, they make fun of, it's in love with Pinot Noir, and they talk about Merlot. Do you know the movie?
I can't remember.
Anyway,
Entre amigos.
Anyway.
In Spanish, entre amigos.
Yeah. The best part was when the woman hit this jackass man in the area that hurts with her motorcycle helmet. That's the part of the movie. But the movie spends most of the. There have been papers in the Journal of Wine Economics showing that this movie statistically significantly changed the price of Merlot versus Pinot Noir in California. Just because the whole movie makes fun of Merlot, but French people make fun of it too. And then that's what they're worried about in Merlot, so they make terrible, overripe, flabby Merlot. So, but the adapters are saying, no, we can deal with this. We're going to move the Merlot here. We're going to change the blend. We're going to rip it out. Ripping out vines is like usually expensive, but that's what some of them we talked to are already doing, right? So anyway, so I think you could do this. So let's talk about how we can get an RCT in Bordeaux, and we have to drink the vintages, and we have to do it for at least the next 10 years. At least, right? T was 10 isn't even. But anyway, yeah. But I mean, let me make one other semi-serious comment. I know I was reading something, and then someone said, well, talking about market systems resilience, and someone said, well, market systems will be more resilient when there's more competition. Sounds like something an economist would say. It's not at all apparent to me that that's true, right? You know, that if you have a lot of competitions, margins are thinner, who survives, who doesn't. And more particularly, there's a QJE paper a couple of years ago by Rocco, I always call him Rocco Machiavelli, but that's not his correct name. You know what I'm talking about? Anyway, but they were looking at the coffee value chain in Rwanda. And they basically look at very interesting kind of nonlinear relationship between degree of market competitiveness and farmer productivity. And the argument is, if you're in a more monopsonistic kind of situation in the coffee value chain, then the coffee value chain trusts the farmers and gives the farmers fundings. Okay. And then when the market becomes more competitive and farmers can sell their coffee here, there, no coffee miller in their right mind is going to lend the farmer money. So it turns out that as competition in that value chain goes up, productivity goes down because farmers have lost the ability to use their coffee as a collateral, right? So that's just one example of, I mean, it's a fairly sensible, maybe highly idiosyncratic, but in a low capital market access environment, that it's not necessarily clear what will make a market system more resilient. So that's one of the examples I like. I think you need to actually measure what we mean by resilience. And then once we measure it, then we can see whether more competition or less competition, or and not that I want to say competition always lowers resilience, but clearly in some environments, it's easy to imagine that it might. So I think that's where I think there's a lot of work that can be done, you know, in this kind of stuff. Anyway, any other questions?
¿Alguna pregunta? Pues
Okay, well, thank you.